Question 1 asks which of the following are perfect squares, perfect cubes, or both? And here's the solutions and the reasons why. 81 is a perfect square because it is equivalent to 9 squared. 64 is a perfect square because it's equivalent to 8 squared. 64 is also a perfect cube because it's equal to 4 cubed. 125 is a perfect cube because it's equal to 5 cubed. 121 is a perfect square because it's equal to 11 squared. 729 is a perfect square because it's equal to 27 squared. You could use your calculator to check that by taking the square root of 729. 729 is also a perfect cube because it's equal to 9 cubed. And 196 is a perfect square because it's equal to 14 squared. Evaluating a number with prime factorization is equivalent to making a factor tree. So if you know 144 is 12 times 12, which is 6 times 2 and 6 times 2, and you continue to do this process, so you get 3 times 2 times 2 times 3 times 2 times 2, you can write that 144 is equivalent to 3 times 2 times 2 times 3 times 2 times 2, all of these factors. And now we look for partners. So the square root of 3 and the square root of 3 is the square root of 9, which escapes as a 3. This 2 and this 2 can partner up, as can this 2 and this 2. And when they escape, they become equal to 12. 3a, 11. 3b is 6 because it's 6 times 6 times 6 is 216. And for the last one, if you think about it as the cube root of 8 times the cube root of 1,000, you don't really need a calculator because that's 2 times 10, which is 20. And 20 times 20 times 20 is the 8,000. To find the dimensions of the cube, we realize that the volume is length times width times height, or length times length times length, because all the dimensions are the same. And if the volume is 1331, then to find L, I take a cube root, and grabbing my calculator, I can find that the cube root of 1331 is equal to 11, and don't forget the units. Square garden of 81 meters squared. She wants to build a fence around the outside, so I need to know the lengths. It's a square, so the area of the square is L squared. In this case, it's 81 equals L squared. Taking the square root gives me 9 meters on each side, and so the perimeter is 4L, which is 4 times 9, which is 36 meters, and the cost is $15 for each meter. So the cost is 36 meters times $15 a meter, which gives me a grand total of $540. Say we multiply -4 and 2 and get -8 and make the exponents positive by making it 1 over x to the 8. For this one, these negatives come to the numerator, joining the positives give you s to the 6. Or you can think about the subtraction rule. You're subtracting away -3, which is adding 3, which is also s to the 6. Same rule, subtract away, so you get -2.6. 4 minus -2 gives you positive 6. And a negative to the power of positive 6 will, 2 negatives will make a positive, 2 negatives will make a positive, 2 negatives will make a positive. So these are equivalent to each other. The negative signs disappear because of the even distribution of negative signs. That one is a bit tricky. When this -3 comes to the top, it joins the top, so you get 4k to the positive 5, or 2 minus -3 becomes 2 plus 3, which is 5, and we should apply the 5 to both parts. So calculating this out, I get 1024k to the 5. Use a calculator for that part. Easily without a calculator, 3 to the -2 to the -2, multiply the -2 and -2, get 3 to the 4. 3 times 3 is 9. Times 3 times 3 of another 9 gives you 81. For B and C, use a calculator. If you have a problem calculating those, then come see me or ask a friend. For the last one, because we've got some algebra in here, we don't want to be using a calculator anymore. So this -2 gets distributed, so I get 4 to the -2 and x to the 4. And this 3 gets distributed, 4 to the 3 and x to the 3, still inside these squared brackets. These negatives want to go down, so they join up with the 3 that's on the bottom. These 4 and these 3 try to cancel each other out, leaving a single x on the top. Don't forget that we're still squaring things, so we get x squared over 4 to the 10th. 4 to the 10th is a huge number, so we can either leave it as 4 to the 10th or grab our calculator to calculate that part out. View a formula for the height that a ball bounces after n bounces. So at the top of the first bounce, we would substitute an n, so at the top of the third bounce we substitute in a 3. We do that on the calculator and we get about 1.029 meters high. It wants to know how long it takes to get to 0.5 meters, so the only way that we can do this is guessing and checking. So you can check it after 4 bounces by plugging in a 4, after 5 bounces, etc., etc., and by doing that you should find that it reaches that height after 5 bounces. Number 9, the formula is given to you in 5 weeks, where n is the number of weeks. You just substitute in a 5 on the top and it becomes a calculator question. For 4 weeks ago, just make sure that you're using a negative. 4 weeks ago is negative 4 weeks. Quite similar to 9, in which we just need to find out n and substitute it into the formula. So here we've got after 1 year, after 2 years, and after 3 years, just substituting it in and using your calculator. Since it started in 1993 and it's going to 2007, for B you want to use n is equal to 18, and this is very similar to B, where we're going into the past, and so now n is equal to negative 3. And again, we just substitute it in and use the calculator to figure out the population. Round your caribou to the whole caribou. Remember, round down. So when you're checking the answer key, just remember that. Got some definitely tricky questions to it. We multiply these two numbers together, and multiplication works. So just do it on the side over here. Multiplication works with some cross-canceling happening, and so you get x is equal to the negative 1/3. Remember, exponents need to be positive, so that can also become x to the positive 1/3. For B, when you're dealing with decimals and fractions, we do want to do the rule, which is subtract the negative. It's easier to work when they're both decimals and both fractions. You can choose which you'd like to work with. I prefer changing this to a decimal. 2 negatives make a positive. 0.4 and 0.6 is 1, so this is equal to 4 to the 1, which is just equal to 4. C is definitely tricky. We need to apply this negative 3/4 to both parts, so we get 16 to the negative 3/4, and we also get g to the 8th, and that 8 is going to multiply by negative 3/4 because you multiply these two numbers together. 8 times negative 3/4 is the same as 8 over 1 times negative 3/4. Cross-canceling gives you g to the negative 6. And I'll give myself a little bit more room. The 16 to the negative 3/4 becomes 16 to the negative 3/4. Both of these are negative, so now we can do 1 over 16 to the 3/4 times g to the positive 6. 16 to the 3/4 can be thought of as the 4th root of 16 cubed. And the 4th root of 16 is what 4 numbers are exactly the same, which is 2 cubed, and 2 cubed is 8. So that's why this is equal to 1 over 8 times g to the 6th. D, this 1/2 is the tricky part. Dividing by 1/2 is the same as multiplying by 2. Division by 1/2 is the same as multiplying and reciprocal, so multiplying by 2. So this 1/2 actually comes to the top as 2. Then you get 2t squared over t to the negative 1/3. I would deal with both of these together before you apply the cube. The subtraction of 2 minus negative 1/3 requires common denominators. 6/3 plus 1/3 is 7/3, so I get 2t to the 7/3, all raised to the power of 3. The 3 applies to the 2, 2 cubed is 8, and the 3 applies to the 7/3, and 7/3 times 3 over 1, 3's cancel, and give you t to the 7. Definitely some tricky questions in here. 12. So mental math and some shortcuts. A negative exponent means flip this fraction over, so you get 3 over negative 1, which is just negative 3, and this is a cube root, and the cube root of 27 is 3, and so you get negative 9. Remember those shortcuts, they're really helpful. 13, so I have the same base multiplied, so I add these exponents. This is like the other one where it's easier to think about this as a decimal place. So 0.4 plus 0.4 is to the 0.8. You'll need a calculator to finish that one off. For the next one, you multiply these two together, so negative 2/3 times 3, think about it as over 1. You get some cross-canceling. That's equal to 3 to the negative 2. 3 to the negative 2 is 1 over 3 squared, which is 1 over 9. For the next one, you have the same base, so you subtract exponents. You get 0.5 to the 0.5 minus negative 2, all to the fourth. 0.5 minus negative 2 is plus 2, so you get 0.5 to the 2.5 to the fourth. Multiplying these together gives you 0.5, and 2.5 to the fourth gives you to the power of 10. 0.5 is the same as 1/2, all to the power of 10. 1/2 to the 10 is 1 to the 10th over 2 to the 10th. 1 to the 10th is 1. And 2 to the 10th is a pretty big number. You should have 2 to the 5th memorized, but 2 to the 10th is pretty big, so grab your calculator. 1024. For the last one, it's easiest to use that quick little change of base. So 8 is the same as 2 cubed to the fourth, and that's divided by 2, and 1/2. This becomes 12, so you get 2 to the 12 over 2 to the 1 to the 1/2. And that's equal to, subtract these exponents, 2 to the 11th to the 1/2, which is 2 to the 11 over 2, or 2 to the 5.5, and again, use your calculator to calculate that one. For number 14, Barb did a really good job with the variable part. 2/3 times 4 is 8/3, so she must have made a mistake with the 27 to the 2/3. You should think about that as the cube root of 27 squared. The cube root of 27 is equal to 3, and 3 squared is 9, so I guess she doubled it to get her 18. Number 15 is a calculator question where you just have to substitute in 3 for the numerator, so hopefully you can use your calculator to do that one. It's a bit tricky because we've been substituting in for variables like in number 15, but now number 16 we're substituting in for this s value. It gives us a speed of 145, and we have to try to figure out what that depth is, and the depth says in there it's in kilometers. The only way that you know how to do this, or you can do this, is guessing and checking. So start by putting some numbers in here. If the value is too high, once you take the square root and multiply it by 356, then try lower numbers. So guess and check is really your only solution to this one. That's fast. You can divide both sides by 356. Dividing both sides by 356 will give you d to the 1/2 equals approximately 0.4073 and a bunch more decimal places. To go from a square root of d to a whole d, we actually want to square this side, and you'll notice 1/2 times 2 multiplies to d to the 1, and if you square one side, you have to square the other side. So if you have all those decimal places on your calculator and you square it, you'll get a depth of about 0.165896 and a bunch of decimal places. You probably round that to about 0.17 kilometers. 17 is a calculator question. We don't have to do much work, just substitute in the 10,000 here. Make sure you plug it in the calculator properly, and you should be able to get the answer. Again, if you can't use these calculators properly, swing by or ask a friend. Make sure you know how to use them properly. Practicing writing these as radicals, so if you write these exponents on a slant, you can see that it's x cubed and it's the 5th root. These denominators become the index. So this is 27t squared is going to get squared, and it's going to also get a cube root. Think about 0.5 as 1/2, and you'll quickly get that this is the square root of g cubed over 18, and you don't need the 2, so make sure it's not there.